Hello friends, welcome to Bhavesirki online class.
Friends, today we are going to see exercise 7b, and you need to know one law very well, that if two bases are equal, what I mean to say here is I am having 5 raised to a is equal to 5 raised to b. Here there are two terms given to us, one on either side of the equal to sign. Left side we have 5 raised to a and right side we have 5 raised to b. What is the speciality of this particular equation? Both the bases are equal, 5 and 5. Remember, if bases are equal, then we can equate the indices also. If this is the condition, that means I will able to say a is equal to b. My dear friends, this is the most important result. We are going to make use of this result in upcoming exercise in multiple times. Now first question, sub question 1, it is given to us 2 raised to 2x plus 1 is equal to 8, and we are supposed to solve for x. We have to find the value of x. So left hand side I have written down as it is. I know 8 is nothing else but 2 raised to 3. Now if you remember that result what we did just now, if bases are equal, then I can equate the indices. So 2x plus 1, that is the index of left side, is equal to index of right side, and hence I can solve this equation because this linear equation in one variable, which you have done it multiple times in lower standard. So ultimately x value is equal to 1. This is very simple exercise. Only few questions will be difficult. I'll be telling you which are those. You have to remember this result without fail. Dear friends, one more question. Question 1, sub question 4, that is given 49 whole raised to x plus 4 equals 7 square into 343 whole raised to x plus 1. As I told you that bases should be same. So here if you observe it carefully, 49 is a square of 7 and 343 is a third power of 7. So I will convert everything in the power of 7. So what I'll get here is 7 squared whole raised to x plus 4 is equal to 7 squared multiplied by 7 cubed whole raised to x plus 1. Now my dear friends, you have to be very careful over here. Here we are going to make use of the concept a raised to m whole raised to n is equal to a raised to m into n. This 2 will be multiplied to the binomial, and whenever we are multiplying monomial by binomial, this monomial will multiply to each of the term of the binomial. Hence left side 2 will be multiplied to x, that is 2x, 2 will be multiplied to 4, that is 8. Over here what happens, 7 raised to 2 into 3, this 3 has to be multiplied by binomial, that is 7 raised to 3x plus 3. Now right hand side there are two bases, same bases, and they have powers, so I can add them up. 2 plus 3 will be 5. Now if you remember the previous question and this particular concept, if you remember, I can equate the powers because bases are same. So I get 2x plus 8 is equal to 3x plus 5. And my dear friends, now this is linear equation in one variable. I can solve this equation. The equation will be solved like this. 8 minus 5 is equal to 3x minus 2x. So ultimately x will be equal to 3. This is your answer. So again, what is the key point here is to make the bases equal, and once the bases are equal, apply this particular concept. If bases are equal, then we can equate the indices. In the previous video we learned that how to convert this square root sign or nth root of a number in the form of an index. So square root of a number in the form of index can be written down as raised to half. So I am removing this square root sign and I am writing raised to half. Both means one and the same thing. And 16 being power of fourth power of 2, I can write down it as 2 raised to 4. Now what happens here is 2 raised to x plus 3. X plus 3 into 1 is x plus 3 divided by 2 is equal to 2 raised to 4. And what you did in the previous question, two questions what we did, if bases are equal, then you can equate the powers. So I am equating the powers, x plus 3 over 2 equals 4, and for the solving is very simple. So here key point, if you have forgotten that square root, then it becomes 1 upon 2. If it is cube root, 1 upon 3, so forth and so on. You have to remember. Rest things are the same. Bases are equal. You can equate the indices. Dear friends, we are taking almost similar category of question. Cube root of 2 upon 3 whole raised to x minus 1 equal to 27 upon 8. So first of all, I will look at this part. I can write down 2 upon 3 whole raised to 1 upon 3. Instead of writing it down as square cube root of 3, I have written power as 1 upon 3 whole raised to x minus 1. So what happens to left hand side is 1 into x minus 1 will be x minus 1 upon 3, and base remains as 2 upon 3. So it is 2 upon 3 whole raised to x minus 1 divided by 3. What happens on right side that we shall see, 27 is cube of 3 and 8 is cube of 2. So I am writing it down as 3 cube upon 2 cube. Now something very interesting, I can write it down as 3 upon 2 the whole cube. Now comes the catch over here. We have done till now so many questions we have done where we equated the powers if the bases were same. Now here the base is 2 upon 3 on left side and right side base is 3 upon 2. Both the bases are not same, so I have to make the bases equal. So what I am going to do, you observe it carefully, I am going to apply one of the rule of indices. I hope you remember this rule that a raised to negative m is 1 upon a raised to m. And this extended rule of this is p upon q whole raised to negative r, then it can be written down as q upon p whole raised to r. I hope you remember this rule. So I'm going to use this particular part on right side of the equation. It is 3 upon 2 the whole cube, so I can write it down as 2 upon 3 whole raised to negative 3. Now what you can observe is base on left hand side and base on right hand side is equal. So what can I do over here is x minus 1 whole upon 3 is equal to negative 3. I have done equating the powers because bases are same. So this was speciality of this question was converting cube root of a number as a power of 1 upon 3, and then the bases were not equal, so I had to take the multiplicative inverse and the power was changed from positive to negative. If it would have been negative, it would be converted to positive. So this is not a difficult question. Again, of course, solving part. We are going to see a super special question. And why I call it a super special? Not because it is a difficult one, but it has two applications. One application is based on chapter number 5, factorization. And second application is based on product of two numbers is 0, then what can happen? We discussed in one of the videos earlier that if product of two numbers is 0, that means a into b equal to 0, then either first number will be equal to 0 or second number will be equal to 0. What I mean to say is either of the number has to be 0, otherwise this product is not true. This particular concept along with the concept of factorization we need to know, and then only we'll able to solve this. Of course, it is a based question on indices, laws of indices, along with the factorization, along with this particular concept. So it's not difficult. It's a chain of things you need to remember. Now it is 2 over here, so I can write down 3 raised to x square over 3 raised to x equal to 9 upon 1. Now if I apply the laws of indices over here, left side will become 3x square, 3 raised to x square minus x equal to 3 squared. 9 is 3 squared, 1 we can avoid it. Now we will apply the rule. If the bases are equal, then we can equate the powers. So I am equating powers. X square minus x is equal to 2. I am bringing that 2 on left hand side. So what I get, x square minus x minus 2 equal to 0. If you remember the factorization, I am splitting up the middle term. It states as x square minus 2x plus x minus 2 equal to 0. Therefore, x into x minus 2 plus 1 into x minus 2 equals 0. X minus 2 into x plus 1 is equal to 0. My dear friends, this entire part we have already studied in very much detail in chapter number 5, the left hand side. Now we are going to make use of this particular concept. If product of two numbers is 0, then either first number is 0 or second number is 0. So here product of two numbers, first number is x minus 2. So I can say x minus 2 equal to 0. or x plus 1 is equal to 0, which will fetch me x is equal to 2 or x is equal to -1. Such kind of equations are called as quadratic equations. More application of quadratic equations we shall study in grade 10. I would revise this question quickly. You need to know the laws of indices, you need to know the splitting up middle term, and you should know the rule that if product of two numbers is 0, then either of the number is 0. And this question is very interesting one, and you have to be a little more careful whatever we are doing in this particular question. They've given us a long equation. First of all, 8 into, this can be written down as 2 raised to x raised to 2 plus 4 into, if you remember in first exercise we did that we can split it up. If the powers are added or subtracted, we can split it up the powers, plus equal to 1 plus 2 raised to x. Now I can see this 2 raised to x at multiple places, and it may be giving me a little trouble. I'm talking about this particular part. Fine. So what I'm going to do, I'm going to get rid of that 2 raised to x. So what I'm writing down, substituting 2 raised to x is equal to y. So what will happen here? 8 into 2 raised to x is replaced by y whole raised to 2, that is 8y square, plus 4 2s are 8. 2 raised to x will be replaced by y is equal to 1, plus 2 raised to x will be replaced by y. This becomes 8y square plus 8y minus y minus 1 equal to 0. This will fetch us 8y square plus 7y minus 1 equal to 0. My dear friends, previous question what we did was splitting up the middle term. So we should understand how can we split up the middle term here. 8y square plus 8y minus y minus 1. The 7y has been split up as 8y minus y. Now here I can take out 8y common, y plus 1. From these two terms I can take out -1. Y plus 1 is equal to 0. So y plus 1 into 8y minus 1 is equal to 0. So y plus 1 is equal to 0, or 8y minus 1 is equal to 0. So I will able to get y is equal to -1 or 8y is equal to 1. So y is equal to -1 or y is equal to 1 upon 8. Now my dear friends, most of the time what you do is you think that this question is finished. My dear friends, question was not y, question was to find out x. So what I'm doing is I'm resubstituting. My dear friends, question number 5, it's not difficult, it's a little different kind of thing. Again, as you can see, there are two variables m and n to be calculated, and all the three bases 4, 16 and 8 are different. So first thing you have to do is make the bases equal. So this 4 I am writing it down as 2 squared whole raised to 2m, which will be equal to 2 2s are 4, so this will be 2 raised to 4m. What happens here is 16 raised to 1 upon 3 whole raised to -6 upon n. I hope you remember this. Cube root of 16 is 16 raised to 1 upon 3. Now this is 16 raised to 1 upon 3 into -6 upon n. This will look like this. Now of course 16 I will write it down as 2 raised to 4. I'll write down 2 raised to 4. 3 and -6 will give us -2 upon n. This was 2 raised to 4m. What happens to the third term? Square root of 8, I can write it down as 8 raised to half whole raised to, and I made an error here, question part is 2 here, so this is 2. Half and 2 multiplies and we get only 8. Again, as we discussed earlier, 8 has to be made as a base of 2, it is 2 cubed. Now my dear friends, something very interesting. One has to know that if A is equal to B and B is equal to C, it means all three of them are equal. So I can equate A with B, I can equate B with C, or I can equate A with C. Why I explained this is because of this particular part. Here 2 raised to 3 has no variable in its power. In the case of 2 raised to 4m has one variable. So this green part and red part I will be equating. So what I get, 2 raised to 4m is equal to 2 cubed. And now I apply that rule that if bases are equal, then powers can be, or indices can be equated. So 4m is equal to 3. So ultimately m will be equal to 3 upon 4. I equated these two things. One more thing I can equate is these two things, right? So it is 2 raised to negative 8 upon n is equal to 2 cube. And now my dear friends, you can equate their indices. So you got two different variables, m and n. It's not difficult. It was little different because there were two variables involved, and you have to learn that if three things are equal, then first will be equal to second, second will be equal to third, as well as first will be equal to third. Question number 6 is based on chapter number 6. Of course, we shall see chapter number 6 little later, but I will explain you the conceptual part of this particular thing. And if you are finding it little difficult, then do not worry about it. Once we do chapter 6, this will be very simple for you. Right now we go as per the indices rules. This becomes 32 raised to 1 upon 2 whole raised to x. No difficulty whatsoever it may be. Divided by 2 raised to y plus 1. This is 32 raised to x upon 2 divided by 2 raised to y plus 1. This is 2 raised to 5 whole raised to x upon 2 divided by 2 raised to y plus 1. Instead of division, I am writing it down as upon. Instead of this division, I am writing it down as upon 2 raised to y plus 1. Now, further what we understand is 2 raised to 5x upon 2 is equal to this particular division. If it goes other side, it will be multiplied by 1. So 1 into any number is number itself. I can say 2 raised to y plus 1. What can you see here? Both the bases are equal. So I can equate the powers, that is 5x upon 2 is equal to y plus 1. I am taking that 2 on the other side, 2 into y plus 1. So ultimately I get 5x is equal to 2y plus 2. Therefore 5x minus 2y will be equal to 2. My dear friends, as I told you, this is based on chapter number 6, simultaneous linear equations. Because here two variables are involved, it's not difficult to solve this particular thing. But we have to stop here for a while, that we got one equation. We shall get another equation, and further how to solve that also we shall see. This is the first equation we got. Now we are given one more equation, and from that we will find it out. We'll frame the second equation. Once that equation is framed, we will able to solve equation number 1 and 2. Let us see how can we frame second equation. Second equation mentions that 8 raised to y minus 16 raised to 4 minus x upon 2 is equal to 0. What I'm doing is I'm making two separate sides. Negative 16 goes on other side, so positive 16. Now bases are not same, so I'll try to make the bases same. This is nothing else but 2 cubed whole raised to y. Therefore this will be 2 raised to 3y. And what happens on right hand side is 2 raised to 4 whole raised to, I made an error, I'm correcting it, it is x upon 2. So 2 raised to 4 whole raised to 4 minus x upon 2. Now I hope you remember that rule. This is a binomial. This 4 will multiply to each of the term. So it will be 2 raised to 16 minus 4 and 2. 2 in the denominator. So it will be 16 minus 2x. Now what I see is 2 raised to 3y is equal to, already we have equated, 2 raised to 3y is equal to 2 raised to 16 minus 2x. Now bases are equals, so what I will do is I will equate the powers. 3y is equal to 16 minus 2x. This negative 2x I am bringing here. 2x plus 3y is equal to 16. This is my equation number 2. Here this was equation number 1. Now what I am going to do is very interesting. I will get rid of one of the variable. Observe this, what I am going to do. I am multiplying equation 2 by 2. When I say multiplying equation 2 by 2 means each term of that equation will be multiplied by 2. 2 into 2x, I will get 4x, plus 2 into 3y, I will get 6y, is equal to 2 into 16, that is 32. So I obtained a new equation. I will label that as equation number 3. About equation number 1, I am multiplying equation 1 by 3. So 3 into 5x, 15x, 3 into negative 2y, negative 6y, 3 into 2 is 6. This is my equation number 4. Now why did I multiply? You will realize just now. What I am going to do is I am adding equations 3 and 4. And when I say adding equations 3 and 4, x will be added to x, that is 4x plus 15x, 19x. 6y minus 6y becomes 0. 32 plus 6 becomes 38. So x becomes 38 divided by 19. So x will be equal to 2. My dear friends, we are not supposed to find out only x, we are supposed to find out y also. So what I am going to do is I am going to substitute x equal to 2 in any one equation. I am substituting in equation 2 right now. So in equation 2 states that 2x plus 3y equal to 16. Out of that 2x, that is 2 into 2 plus 3y is equal to 16. Therefore 3y will be equal to 16 minus 8. Sorry, 16 minus 4, that will be 12. 2 2s are 4, 16 minus 4 is 12. So y will be equal to 4. So you got two answers. One is y equal to 4 and other is x equal to 2. This is called as solving simultaneous equations. Question number 8, let me tell you, it's a super special question. It's totally different. They're given a raised to x equal to b, b raised to y equal to c, and c raised to z equal to a. And we are supposed to prove that product of x, y, z is equal to 1. Now, you must be aware of that. Whenever we are proving something, it is not solution, it is proof. I start with first thing given, that is a raised to x equal to b. Now, if you remember, we can square both sides, we can cube both sides, we can take fifth power of both sides. So what I am taking white power of both sides. That means I am increasing to power. Bs means both sides. I am increasing to the power raised to y. So a raised to x whole raised to y is equal to b raised to y. You know this rule, a raised to x y is equal to b raised to y. My dear friends, what is b raised to y? Just check it out over here. B raised to y is nothing else but c. So this b raised to y I will substitute as c. Just check it out over here. So my new equation is a raised to xy is equal to c. Now taking z power of both sides. It will read like a raised to xy whole raised to z is equal to c raised to z. What this becomes is x raised to a raised to xyz is equal to c raised to z. My dear friends, just check it out. What is the given condition? C raised to z is nothing else but a. So I can replace c raised to z. The c raised to z I can replace by a. A is nothing but a raised to 1. Now if you remember, if the bases are equal, then I can equate the powers. So here powers are x, y, z equal to 1. So I told you it's a super special question. Prove that x, y, z equal to 1. We got the conclusion. Once taking white power, other time taking z power. You have to practice this 2 or 3 times minimum. And this is another super special question. Question number 9. A raised to x equal to b raised to y equal to c raised to z. That is one of the given condition. Other given condition is b square equal to ac. We are supposed to prove that y is equal to 2xz whole divided by x plus z. Let's see the proof. Not difficult one, but different one. They are given a raised to x equal to b raised to y is equal to c raised to z. All three of them are equal. Let's say its value may be all three of them are equal. Their value may be 100, 200, 500, something, some number, but we do not know what is that number. So I am considering that number as k. Now I can say a raised to x equal to k, b raised to y is equal to k, c raised to z is equal to k. Now if you know that if I am having p square is equal to say q, then I can take square root. So p will be equal to under square root q. That means if some power is there, I can take that particular root of that particular number, and root will be taken on both the sides. So what I am taking is, in this case I am taking xth root. So it will be a is equal to k raised to 1 upon x. B will be equal to k raised to 1 upon y, and C will be equal to k raised to 1 upon z. I have taken the corresponding powers root. Like here it was x power, I have taken x root. Here I have taken y root, and here I have taken z root. Now they have given one more condition, b square equal to ac. So let us write down b square equal to ac. This is given to us. B square, b can be replaced by what? K raised to 1 upon y whole raised to 2. A can be replaced by what? K raised to 1 upon x. C can be replaced by what? K raised to 1 upon z. This becomes k raised to 2 upon y is equal to k raised to 1 upon x plus 1 upon z. Now their bases are equal. So what can I say is 2 upon y is equal to 1 upon x plus 1 upon z. 2 upon y will be equal to, here 1 upon x and 1 upon z. I hope you know how to equalize the denominator. So this will become z plus x whole divided by xz. I am taking inverse of both sides. Y upon 2 is equal to xz upon z plus x. I have taken multiplicative inverse. ये p upon q था, तो यहाँ पर q upon p कर दिया. तो same thing will happen. Other side also I have to take the inverse. Now this 2 if you take it on other side, y will be equal to 2xz. You just see y, if I take this 2 on the other side, I am writing it clearly. Here is 2. If I take this 2 on other side, it will look like this. Y is equal to 2xz whole divided by x plus z. And that was what we wanted to prove. And remember, the most important part in this particular question was first equating to k and taking the corresponding roots and substituting them at a correct place. Question number 10, and if you have done question number 9 correctly, if you have understood question number 9 correctly, this will not be much difficult. This is again a super special question. So again, let us show that, prove that. The solution will begin with proof. 5 raised to negative p is equal to 4 raised to negative q is equal to 20 raised to r. This is the given condition. And if you remember, in previous question what we did was we equated all the three to one particular number, and that was k. So I am considering let 5 raised to negative p is equal to 4 raised to negative q is equal to 20 raised to r equal to k. That will fetch me 5 raised to negative p equal to k, also 4 raised to negative q equal to k, also 20 raised to r is equal to k. If I want to convert this negative power into positive power, I can write it down as 1 upon 1 upon 5 whole raised to p equal to k, 1 upon 4 whole raised to q equal to k, and 20 raised to r is equal to k. I am taking the corresponding root of each number, that is 1 upon 5 will be equal to k raised to 1 upon p, 1 upon 4 will be equal to k raised to 1 upon q, and 20 is equal to k raised to 1 upon r. I have taken the corresponding roots. Now I know this 20 is equal to 5 into 4. We know this very well. That's a very simple factorization. Now 20 can be replaced by k raised to 1 upon r. If I take this 5 as 1 upon 5, then it will be raised to negative 1, and 4 can be written down as 1 upon 4 whole raised to negative 1. What is the value of 1 upon 5 in terms of k that we shall see? It is k raised to 1 upon p whole raised to negative 1 into k raised to 1 upon q whole raised to negative 1. So this becomes k raised to 1 upon r is equal to k raised to negative 1 upon p minus 1 upon q. So I can say 1 upon r is equal to negative 1 upon p minus 1 upon q. And if you understand this, I am bringing every term on left side. So 1 upon p plus 1 upon q plus 1 upon r will be equal to 0. So key point to convert everything in a particular root, and then substitute 20 के जगह पर k raised to 1 upon r, 5 first convert into 1 upon 5, then substitute, you get negative numbers, and then bring those negative numbers on right hand side. And here I made an error, it's not equal to 10, equal to 0. Please take a note of that. Starting part it was showing 10. It is 1 upon p plus 1 upon q plus 1 upon r equal to 0. We have proved that particular thing.